All right, so we are starting our new unit today, sequences and series. You'll notice this is day 2. That's just because there's a intro activity that I usually do with this on day 1 that we're going to skip just because it's not that feasible to have you do group work over remote learning. So we're just going to go ahead and jump right in. So arithmetic sequences are basically, sorry, Watson is very upset about something right now. It's probably a squirrel in the front yard or maybe a bird, something like that. So you'll hear him in the background. Okay, sorry. So an arithmetic sequence is a sequence in which the difference between any term and the previous term is constant, okay, meaning the same. So as an example of this, counting by twos is this arithmetic sequence, 2, 4, 6, 8, 10, 12, because you're constantly adding the difference of 2. Okay, if I start with the number 5 and keep adding 2, so 5, 7, 9, 11, that's also an arithmetic sequence because I'm adding a constant difference of 2. Okay, so that's all we're talking about here. It's just a list of numbers that there's something that's been added every time. Okay, the difference D, if that is positive, then your sequence will be increasing. Obviously, if you're always adding something and it's a positive number, it's going to go up. If D is negative, then the sequence will be decreasing again, obviously, because if you start with something and you keep adding negatives, it's going to go down. All right. Now, when we look at arithmetic sequences, you can just look at them as a list of numbers, but you can also consider them to be functions. Okay, so we can also consider these to be a function in which the domain is usually the set of non-negative integers. And you're thinking to yourself, why would you say non-negative? Why not just say positive? 0. Okay, a lot of times using 0 as the domain will actually make your life a lot easier, and we'll touch on that later. Okay, if we just said positive integers, that would just be 1, 2, 3, 4, 5 and not include 0. So sometimes people will use just the positives, some people use the non-negatives. It's kind of a preference thing for the most part. Okay, and then your range is just your set of your terms in the sequence. Okay. All right, so just some simple notation. The terms, which are the numbers in your sequence, we call those their A's, and then use little subscripts just to enumerate which term in the sequence it is. Okay, so for example, with this guy here, 2, 5, 8, the dot, dot, dot means continue the pattern. This guy right here would be A1 because it is the first term in the sequence. This guy would be A2 because it's the second term in the sequence. This guy would be A3 because it's the third, and so on. So nothing super special there. Yes, those are lowercase a's. That's just how my handwriting works. You do want to use lowercase a's here. Okay, your common difference, D, and the number of terms in your sequence, or at least the number of terms that you're looking at, would be n in your sequence. Okay, so let's start looking at some examples. So a big part of doing arithmetic and geometric sequences and series is like engaging your brain and just thinking logically about them. Okay, so let's talk about this guy right here. We want to find the 40th term in this sequence. Okay, so we've got the first couple and I want to get to the 40th one. I could look at this and say, well, looks like I'm adding 3 each time, so let me grab my calculator and I'll start at 2 and start adding 3 a bunch of times. Okay, but 1, that's going to take forever, and 2, I guarantee you if I did that, I'd lose count of how many times I'd added that number, and then I'd have to start all over again, and it would be a real pain in the butt. So let's think about how we can do this easier. If I'm adding 3 a whole bunch of times, if I can just figure out how many times I'm adding it, then I can jump ahead and multiply, right? So if I want to go from the first term to the 40th term, how many times am I adding 3? Well, let's think about it. Say I wanted to go from the first term in the sequence, right? So if I want to go from the first term in the sequence, A1, and I wanted to go to just the second term, right? I would have to add D, my common difference, which is 3 in this case, once. Okay. If I wanted to go from A1 to A3, I'd have to add that common difference twice, right? Once to get to the second term, once to get to the third term. If I wanted to go from A1 to A4, I'd have to add it 3 times, right? 2 times to get to A3, and then 1 more to get to A4, right? Okay, if I wanted to go from A1 to A5, then it would be 4 times, right? Okay, well, take a look at for a second and figure out what's my pattern here. Yeah, these numbers are going up by 1, but what's the pattern between these subscripts and this number over here? Well, 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4. So it looks like we've kind of got a pattern here. But the question then becomes, does that only work? Like, we've left all of these as A1. So what if I change that? What if instead of starting at A1, what if I want to start at, say, A2? What if I want to go from A2 to A3? Well, how many times would I have to add D? Just once. They're only one spot apart, right? If I wanted to go from A2 to A6, well, I'd have to add it, let's see, once to get to 3, once to get to the 4th, once to get to the 5th, once to get to the 6th. That's 4 times. So I'd have to add it 4 times. So does my pattern hold? Well, yeah, it sure looks like if you subtract my subscripts, that tells me how many times I have to add a common difference. So if I wanted to go from, say, A sub m to A sub n, all I have to do is figure out what n minus m is, and that'll tell me how many times to add d to that problem. Cool. All right, so back to this guy. So we figured out that our common difference is 3 just by looking at it. We can count that pretty easily. All right, so if I want to go from the first term to the 40th term, right, I would have to add 3. Well, if I'm starting with a 2, which I might as well, it's the first one. From the 2 to the 40th term, that would be 39 times, right? So I'd have to add 3 39 times. All right, so I can figure it out that way pretty easily, right? 39 times 3 plus the 2, bam, it's 119, good. All right, how's this going to show up formulaically, right? Well, if we're thinking about what we're doing, what I'm basically saying here is that if I want to get to the 40th term, I am starting at the first term, and I'm adding my common difference of 3, right? And we said it would be 40 minus 1 times. That's how we got the 31, right? Going from the first to the 40th, the difference between those two numbers. Okay, and I already know what A1 is. I could pull that out from right here. So it's just 2 plus 3 times 39, right? Which also gets me that same 119. Okay, cool. So formula, right? Formula for an arithmetic sequence. All right, I personally, I don't really memorize this formula. I just think about it, right? I can just think about this and always figure out what I need to do without bothering with the formula. Okay, but the technical formula is that to get to any term in your sequence from your starting term, A1, you add your common difference n minus 1 times. Now, this formula only works if you're going from A1 to AN. We're going to see in a minute, this guy, we're not going to go from the first term. We're going from the 6th to the 10th term, which means I'm going to have to modify this formula a little bit to make it work. So I don't really recommend that you just memorize the formula. I'd memorize the concepts beyond what's going on. Okay, so let's look at this guy. We know the 20th term is negative 111. We know the common difference is negative 6, and we want to figure out what A1 is. So I'm going to kind of build this formula. Well, to get to A20 from A1, I have to add my common difference how many times? Well, it's the difference between these two, right? It would have to be 19 times. Then I'm going to add that common difference. Okay, and then I can just plug in the numbers that I know. I know this guy's negative 111. I don't know what A1 is. That's what I'm looking for. But I do know that D is negative 6. All right, and then from here, we've got a pretty easy solve. So I'm doing that 6 times 6 times 19. Sorry, I keep screwing up these numbers. Okay, so this is going to be a negative 114. And then when I add that to both sides, 3. So my initial term, my A sub 1, is 3. And then do a quick check. Does that make sense? If I start with 3 and I subtract 6 a whole bunch of times, does it make sense that I'm going to end up at negative 111? Yeah. Yep, that makes sense. So there we go. All right, now the second guy here, so this is where we're going to have to kind of modify this formula a little bit, okay? Because I'm not going from A1. I'm going from A6 to A10. So let's think about it. If I want to get to A10 from A6, I'm going to have to add my common difference how many times? Well, think about what we did here, right? We said that it was always just going to be the difference between these two numbers. So if I want to go from A6 to A10, my pattern is that I'm subtracting these two numbers. That's going to be 4 times. Then I'm going to have to add my common difference. Okay, once to get to 7, once to get to 8, once to get to 9, once to get to 10. So I'm doing 10 minus 6 is 4 common differences. All right, and then I can just plug in the numbers that I know. This guy's 39. This guy's 25. Common difference, I don't know what that is yet, but we're going to figure it out. And then this guy is a pretty easy solve. So 39 minus 25 is going to be 14. And then divide both sides by 4. That's going to work out to 7 over 2. Right? All right, great. Okay, so now we've got our common difference D, but they also want us to figure out what A1 is. So I'm going to have to build another little equation using now my common difference and figure out what A1 is. So I'm going to look at this and say, all right, I have to start with A1 and get to something. You could use either one of these. It doesn't matter which one. I'm going to use this guy because I like the 25 better. So I'm going to go with A sub 6, but you could use A sub 10. It wouldn't matter. All right, to go from term 1 to term 6, I have to add my common difference 6 minus 1 times. All right, and then I'm going to plug in what I know. This is 25. That's what I'm looking for. Common difference, we just figured out. 6 minus 1 is 5. All right, and then this is all that I'm going to solve. So I'm going to have to multiply those two together. So 7 halves times 5 is 17 and a half. And then I'm going to do 25 minus that number and figure out that A sub 1 is 7.5. So there's the two pieces of information that they asked me for. Okay, and again, it doesn't matter which term you use. I used A sub 6, you could have used A sub 10. So as an alternative to this, we could have also done to get from A10, from A1, you add your common difference 10 minus 1 times. You'll get to the same thing. All right, and then this last guy here. So this last guy is going to ask us to write a formula or a rule that describes this sequence. This is the same guy that we were looking at back here, right? So we already know our common difference is 3, right? So what I'm going to do is I'm going to fill this in using this kind of generic formula that we have. And my generic formula says, sorry, you know how I am about choosing a marker. I got to find a good color. I was going to use red, but we already used orange, and those colors are so similar. It's challenging. All right, so we want a generic rule here. So I don't want to go from a specific term to a specific term. I want to go from the starting term to just any old term in general. So I'm going to say to get to any old term, A sub n, I'm going to start with A sub 1, and I'm going to add my common difference while using that pattern n minus 1 times, right? Just like here, we said it would be 6 minus 1 times. Here we said it was 10 minus 1 times. Here we did 20 minus 1 times, right? Now we're doing n minus 1 times. All right, and then I'm just going to fill in what I know. I don't know what A sub n is, but I know A sub 1, that's 2. That's just the first term in the sequence. All right, my common difference, I know what that is. I can figure that out. It's 3. That's going up by 3 every time. Okay, and then I'm going to leave that as an n because n is going to be my variable in this sequence. Okay, and that is my generic rule. I am going to clean this up a little bit, right? I can make this 2 plus 3n minus 3, and then I can rewrite that as 3n minus 1. And there we go. That's my rule. To find any given term in the sequence, I can use this thing, or here's my shortcut, right? I can just plug in into n whatever term I want. Remember back here, we wanted to figure out the 40th term? Well, if I take this guy and I plug in 3 times 40 minus 1, there's that 119 we found before. So now we found what's called an explicit rule that will jump you to any term in the sequence pretty quickly and easily. right? Now also notice that should look familiar. Doesn't that look like a linear equation, right? Shouldn't it look like a linear equation? Because we're adding something the same time over and over and over again, okay? All right, so that is all there is to arithmetic sequences. They are not horrible. It's very similar to stuff you've done before with linear equations.